Moving into section 2, just some terminology and other protocols of interest. So you're going to hear NTP thrown out a lot. That is network time protocol. It's clock synchronization. That's it. It's going to sync your clock. It's going to make sure that every device that's on the network has the same time associated to it, the same timestamp. It's going to use UDP port 123. And if we think about why this is important, especially from a security concept, is logs. If we have a security event happening on the network, and if my clock over here is an hour off from this one, or even if it's just a couple of minutes off, that can really affect my analysis and statement of confidence for when I can say the malicious activity did occur on the network. So NTP is going to be used as a protocol in all production environments to synchronize the clocks on the computer systems doing it over the network. It's going to do it in a hierarchical manner with one or more time servers at the top of the hierarchy, providing time to all of the lower level time servers, which then go and give the time allocated to the clients. It can operate in unicast or multicast. NTP timestamp messages are used to measure the time delay between the sender and receiver. It's a complex math algorithm, of course it is, because we're working with computers to adjust the clock frequency in small increments, ensuring that the clock is always accurate to within a few milliseconds. So that would be pretty good for our log analysis. It's widely used in network systems such as the internet to ensure the clocks on different systems are synchronized to within, a few milliseconds. So what do you take away from this slide? N2P, it's network time protocol. It's going to be UDP port 123. It's important to use it so that all the devices on our network have the same timestamp associated with them within a few milliseconds. And we would want to use that, especially from a security standpoint, to ensure when we're doing our analysis for a potential security threat on the network, all of the times match up. Revisiting ICMP, remember this was the Internet Control Message Protocol. It was the protocol we talked about to have devices within the network communicate problems to each other through data transmission. So we've covered ICMP. Remember, trick interview question is what protocol and port does ICMP use? Well, it's its own protocol and it doesn't use a port because we're still only at layer 3 of the OSI model at the network layer. So it's not even going out yet. It's no port, and it's using instead new terminology, ICMP types and ICMP codes. So it's going to identify the message by these types and codes, and the type field is going to identify the overall general category of the message, while the code is going to give you a bit more granularity into more specific information about what the message is saying. So for example, if we had an ICMP message and it was type 3 and code 0, that would mean that the network was unreachable. If we had a type 3 code 1, that would mean the host is unreachable. The ones that I would be familiar with is a type 3 code 0, a 3.1, and maybe a 3.3. These might be asked on an interview to say, ICMP type 3 code 1 is what? And you would say, oh, that means the host was unreachable. It's a ridiculous interview question in my opinion because you can always go to Google and say, give me the ICMP types and codes for you to reference, and it's information you don't need to memorize. They ask it because it gives you a better sense of how familiar you are with using network protocol analyzer tools like Wireshark, or if you've seen it before, if you've done any kind of level of troubleshooting, these would be the ones that you would already be familiar with and you'd already have them memorized because you've been working with them and you've seen them a bunch before. So anyways, you have this chart. I definitely wanted to make you aware of, ICMP type and codes, and kind of going down the list here. Type 8 would be an echo request. Echo reply would be a type 0. Type 11 is time to live would be exceeded for code 0, and code 1, the fragment reassembly time exceeded. So it's all about relaying information about paths, routes, and network conditions. All right, what is a proxy server? I would definitely be familiar with what a proxy is and why we would want one. It's going to be an intermediary server that's going to sit between the client and or a device like a firewall or a router, and it's going to act as the middleman. It's going to act as your proxy. It's going to take your data, and before it goes out to the backbone of the internet, it's going to take your packets, going to take your request, take your information, and it's going to send it out on your behalf. It's going to go out using the proxy. This can improve security and privacy within your organization because if you think about it, the receiving end over here, let's say we have receiving server A, when you go to send out a packet requesting a resource from this server, if you just go directly to it without using a proxy, this server now knows your IP address, or at least your, if the router's there and it's being NATed, your company's public IP address. And again, it would convert and you'd have your private IP address, but it would at least know the source that it came from. If we wanted to include some privacy within this and improve security, for one way we can do it is put a proxy there instead. So instead of, we can put whatever IP we want for a public space, and it's going to be making the request for that resource on your behalf, and it's going to show not your IP address, but the IP address of the proxy server. So there is no back mapping to your company or your company's public IP space. It's only going to know whatever IP you're allocating to your proxy server. It can also increase security because if we think about what we want to restrict users from doing or visiting potentially malicious sites on their corporate devices, we can say, no YouTube allowed, no Reddit allowed. We don't want you having any fun at work, so we're going to leverage a proxy to say your request is going to be denied and you're not going to be allowed out to those sites. It's going to deny your request right there. It can also improve network performance as it can cache frequently accessed resources and return them faster to you. It can be, as we just described, control access to resources or act as a filter. You can enforce security policies through this, and you can also monitor network activity. All these things are good use cases for proxy servers, but if you just think of it as an intermediary server between you and a resource or your company, and before it goes out the firewall to the internet, it's going through your proxy server first. That's pretty much all it's doing. These are the different types of proxies you can have. You can have a web proxy server, reverse proxy, an SSL proxy, file transfer protocol proxy, or a mail proxy. Just wanted you to be aware of that terminology, what it is, why we would use one, and how they can be beneficial. This slide is very simple. We are describing the difference between unicast, multicast, and broadcast. So unicast, one-to-one, multicast, one-to-many, broadcast, one to everybody. So, any questions? That's very simple. Unicast, multicast, broadcast. Buzzword for broadcast, 255, 255, 255, 255. If you can ingrain that in your memory as always allocated as the broadcast IP address or 255 ranges, that will be very helpful for when we move into Mod 4 for subnetting and calculating the broadcast address of that network. So, all 255s always allocated for the broadcast IP range. Another overlooked kind of terminology is your network gateway or your default gateway. This is going to connect all of your networks over the core. If we go back to the Cisco model, the core internet, the cloud of the internet, it's going to be responsible for routing the traffic between the network and other networks or devices. So the thing I'm highlighting in blue here is the network gateway is configured with an IP address that usually ends in .1. And that makes it easy to remember and easy for us to identify how traffic's going out of the network is if we know the gateway is always usually .1 to be like, that's the next hop, that's the next route, that's where you're going next. That's how we allocate it. So for example, if our network address was 192.168.1.0 for our network, then the IMP that's usually reserved for the gateway address would typically be set to the .1. So 192.168.1.1. If we had 172.16.10.10, our gateway would still be 172.16.10.1. So if you see the IP address and you see that maybe in your routing tables or being assigned somewhere, just be aware that that's your network gateway, your default gateway, and that's where the next point of traffic for your packet to go is going to go out the gateway and be released to the network.